This is question 22 from the 2008 calculator paper. Here we're told that Katie drove for 238 miles, correct to the nearest mile. She used 27.3 litres of petrol to the nearest tenth of a litre. Then we're given a formula about petrol consumption. Then we're told that we need to work out the upper bound for the petrol consumption for Katie's journey. Give your answer correct to 2 decimal places. So the first thing that we're going to do is let's just write out the upper bounds, and let's choose a better colour pen. Let's work up the upper bound for the number of miles that she travelled. So we'll work out the upper bound and the lower bound. So the upper bound, the furthest she could have travelled, and for it to be rounded to 238 miles, would be 238.5. The shortest distance that she could have travelled, and it be rounded to 238, would simply be 237.5. Now there is a little check that you can do to check that you have correctly counted the upper and lower bound, and the difference between them, the difference between the upper bound and the lower bound should be the same as the accuracy to which the value has been measured by. So it's been measured to the nearest mile, which means that the difference between these two, the upper and lower bounds, should be a mile as well, and we can see that that's right. So 238.5 and 237.5, there's a mile difference between those. Now let's think about the amount of petrol that she used. So we'll work out the upper and lower bound for the petrol that she used. The upper bound, the most amount of petrol that she could have used, and it be rounded to 27.3 litres of petrol, is going to be 27.35 litres of petrol, and then the lower bound is going to be 27.25. So the lowest amount of fuel that she could have used, and it be rounded to 27.3, would be 27.25. Again, let's use our little check. The difference between these two values should be what we've measured here, to the accuracy it's been measured to, which is to the nearest tenth of a litre. So there should be 1/10 between these, and we can see that that's right. There's a difference of 0.1 between them, which is the same as a tenth. So what now? Well, we're asked to work out the upper bound for the petrol consumption for Katie's journey. And we are given this formula that the petrol consumption is equal to the number of miles travelled divided by the number of litres of petrol used. So we need to figure out what is the highest number that we could get from using our upper and lower bounds for miles and petrol. So let's take, what I'm going to do is I'm going to take the upper bound for the number of miles, 238.5, and I'm going to divide that by, and this may seem quite strange at first, but we'll talk about why we're doing this. I'm going to divide that by the lower bound of petrol. Now that may not seem right, because you're thinking we need to find the upper bound, but this will give us our upper bound because this is going to give us the highest possible value for petrol consumption. Because if we think about it, if I was to divide the upper bound by the upper bound, which is the common mistake that people make, then that answer is going to be a larger number, is going to be a smaller number than dividing the highest amount and dividing that by the lowest amount. So I'm taking the upper bound and dividing it by the lower bound. So 238.5 divided by 27.25. I'm going to put this into my calculator, and that's going to give me an upper bound for petrol consumption. So that gives me an answer of 8.75229. I'm asked to give my answer correct to 2 decimal places, so I'm going to say that this is 8.75. So my answer there is going to be 8.75. Okay. Just a further point on the idea of taking the upper bound and dividing it by the lower bound. If you imagine, say, let's take, for example, 8 divided by, say, 3, and then took, say, 8 divided by 4, we can see here that the 8 divided by 3 is going to give us a larger number than 8 divided by 4. So again, just to reiterate here, to find an upper bound for the petrol consumption, we've had to take the upper bound, the highest possible number, and dividing it by the lowest possible number to give us our highest possible number for petrol consumption. Okay, if you didn't quite get that right, take a look at this question here, have a go at it, then press play, and I'll go through it. So the diagram above shows the plan view of a school field. The lengths are measured to the nearest 5 metres. Calculate the upper bound for the area of the field. So first of all, let's take this value here. Our upper bound for this way is going to be 197.5 because it's measured to the nearest 5 metres. My lower bound here is going to be 192.5. Let's just check that's right. If it's correct, it should be the difference should be the same as the accuracy to which it was measured. It is, it's 5. The difference between them is 5, so that must be right. Then let's work out the upper and lower bound for 80. Upper bound here is going to be 82.5. Lower bound is going to be 77.5. Difference between them again, let's just check. Yep, that's 5. That's fine. So then, from this point, I need to calculate the upper bound for the area of the field. So the area, that's going to be the two. That's going to be the two values multiplied together. What's going to give me the highest possible number? That's going to be the upper bound multiplied by the upper bound. So I'm going to do 197.5 multiplied by 82.5, and that will give me the highest possible value for the area of the field, so the upper bound for the area. So 197.5 times by 82.5, that's going to give me an answer of 16,293.75. And that would be the final answer for calculating the upper bound for the area of the field.